Okay, looking at our third and kind of final option, although we'll have a variation on it probably tomorrow. Sine law, the new hope. So just quick review of what we've seen with a right angle triangle in number one here. Right angle triangle, we have our sine, cos, and tan options. That still remains. If you have a question that has right angles in it, you can certainly use those as long as you have the appropriate information for it. We then saw the cosine law. There were two special cases of the cosine law. Side angle side, meaning I have exactly two sides that I know, and I have the angle that joins them given to me. Again, not any two sides and some other angle, the two sides that are joined by the given angle. So side angle side in that order. And if we have side angle side in that order, we can use the cosine law in its normal form. Again, the numbers just go in 75 squared here plus 18 squared. And you'd just be able to punch that straight into a calculator. The second option was if we have exactly and only the three sides. So again, 53, 82, 61. One important thing to recognize here, again, is when we're labeling a diagram, we always consider the sides and the angles that are opposite each other to have the same name. So this is side C here, and this is angle C that I'm looking for. The other two, again, don't really matter. So if I'm plugging in these numbers, I've got cos of the unknown angle. The C has to be the 61, and then the other two can be in whichever order you choose. And again, depending on which angle you're looking for, you choose your different C. So if I were looking for alpha here, then 82 becomes my C. If I'm looking for beta over here, then 53 becomes my C value. So if those don't work, so look at this example. I've got the given triangle. I think this is just a little mistake here. If I tried to use the cosine law, okay, so that's what we've seen before. This is actually a situation, I have two angles, I have one side. So what happens is when I try to plug those numbers in, I'm looking for the x squared. So it's my C value. The 45 degrees would become the angle C. So when I'm looking for the other numbers now, 15 can go in for the A, but then I don't know this value here. And so essentially in my equation, I would end up with two unknowns. So we do need a third option. And as we said, this will be the sine law. The sine law you've likely seen written down before. And it basically relates sine of an angle to the side, to the side that it's across from. So whichever labeling I choose here, actually I'll choose it in a second once I get to solving the problem. So essentially it's saying that I can relate sine of an angle with the side across from it throughout the triangle. Now, hopefully it's fairly obvious, but what I would end up doing is using sort of two of these in solving the problem. I wouldn't actually try to use all three, a two-way equation sort of thing. But it's suggesting that any combination of angle and side across from it can be used in this to solve. So it doesn't have to be the ones labeled A's and B's and C's and D's or anything else. It can be any of the angles that you have. So in this solution, if I did try to look to see, assuming I don't know exactly what I'm doing, I'm choosing the green formula because it has the sides on top, and I'm looking for this x value over here, a side. So just a little hint there. If I'm looking for a side, let's say unknown side, this is a slightly better formula to use. It is the exact same formula, just flipped over. And if we have an unknown angle, which I don't think we will today, but this is a slightly better form to use. So moving forward, if I have this x value, again, the x and the 45 across from it line up to give me the first part of my equation over here. And then the other side that I know is the 15, and it lines up opposite this unknown angle up here. For now, I'll label it theta. And so that's where this comes from. And if I chose to try to use the other side, the angle, the 110, it lines up with the question mark so as to kind of give me, my third possible pairing. I have to choose, obviously, whichever ones will end up working for me. So in order to solve any equation, I always need to have all but one of the variables. I see here I have a missing x. In the second situation, I have a missing theta. In the third situation, I have the question mark. So one of those has to be something that I can figure out without actually solving the equation. And probably you've already noticed that I have two of the three angles in my triangle. That means I can always find the third angle. So theta will be found by subtracting the 110 and the 45 from 180. And I just kind of did that over here. It's 25 degrees. And so once I know that from 25 degrees, it's a matter of solving the question, finishing it up. As I would with any equation, multiply my sine of 45 across. Essentially, I'm multiplying both sides by sine of 45. The sine of 45 would cancel on the left or divide out on the left. And I'm left with this calculation, and x is 25.1. So one more example here. A fire is spotted from two Ranger towers. Tower A is exactly 10.2 kilometers due west of Tower B. Okay, so as I'm creating this question, I read the question. I'm going to fill in the information that I know. I'd already sort of started, but Tower A is to the west of Tower B, and Tower B is to the east of Tower A. 10.2 kilometers between them. The fire is exactly northeast of Tower A. So here's my fire. My angle to that is northeast, and northeast makes it 45 degrees. Okay, so north is directly, if you sort of go to your and northeast, of course, would be halfway between those. 30 degrees. So, and is 30 degrees west of north for Tower B. So if I'm looking at this, I have to be a little bit careful. What it's telling me is it's 30 degrees west of north, which means that in here is my 30 degrees. Okay, so directly north goes 30 degrees towards the west, and that tells me that I will actually have a 60-degree angle on the inside here. Okay, so much like the angle of depression that we mentioned the other day, when we have word problems, you have to be a little bit careful and know what they're telling us. Now that we've got that, the question says find the distance of the closest tower. So when I look at the question, can't go by the diagram itself. It looks as though this line is shorter, so it looks as if that is the shorter side, but I do have to be a little bit careful. Give me a second, I'm going to pause here. Okay, sorry. So I was saying, it looks like this is the shorter length, but of course I can't go by my diagram. I drew it without really knowing what was going on. So when we think about this, now we have two choices. One is go ahead and calculate the length of that line. Go ahead and calculate the length of that line. Certainly nothing wrong with that. But if we sort of think it through a little bit, when this angle is only 45 degrees, and this angle is 60 degrees, that the size of the angle forces the length of the opposite side. And so if we have a 60-degree angle, this side here has to be longer than the other one. And so what I'm seeing is this side over here is the one that is going to be the shortest actual length. And so I can say that B will be closer. Now again, if you don't recognize that, that's fine. Go ahead and solve for both lengths and determine which one is the shorter length. Now, recognizing that I have angle A down here, then sort of, without thinking too much about it, side A is over here. Since I have B already drawn in, then I'll consider this to be angle C and consider this to be side C. And so I've got A over sine A equals C over sine C. Plugging in some numbers, x over sine of 45 is 10.2 over over sine of 75. And I can finish that up. And actually I wrote it a little bit wrong here. It is Tower B. That is 7.5 kilometers from the fire. So those are examples of how to use the sine law for today. As I said, we'll see a little bit tomorrow to get kind of the last special case of the sine law as well.